Thanks again. Thanks to all the organizers. It's a pleasure to be here. So my name is Simha Mummalaneni, at University of Washington. This is joint work with Simha Simon, who's a colleague of mine at job, as well as Bharat Pathak. Him and I met Bharat when Bharat was full-time at Twitter, and that is going to be the sort of data context I'll be talking about here today. As you can see from the title of this talk is about social media platforms, and specifically what happens when specific users receive engagement from other people. How do they react? How do they change behavior after that? And I want to start with what I think is like a relatively simple observation, which is social media platforms are almost entirely ad supported in terms of where the revenue is coming from. These companies don't really sell much, but in order to survive, they are all in the business of showing ads to users. And if that's the case, they also benefit, therefore, from encouraging users to increase their activity on the platform. The longer people are spending on social media, the more ads we get to show them, and therefore the more money. So that's like the relatively simple kind of logic we're relying on. And if we think about ways that we can get people to spend more time on social media platforms, there's a whole bunch of different ways that the previous literature has looked at, some of which I think are more financially reasonable than others. But what we're going to be focusing on here today is this last bullet point that you see down here at the bottom, which is the notion of, one thing that is entirely within the control of the platform itself is the recommendation algorithm. What does the content timeline look like? What does the algorithm look like to individual users? That is obviously within the control of the social media platform. And there's some users out there who really, really crave engagement from others. And if we can figure out who those people are, and if I can help you now get that engagement, these people are now going to presumably go on to spend more time on the platform. So that's the idea. That's what we're going to be focusing on here in this research. And this gives rise to, I think, some relatively related research questions. The first is simply, well, as I've sort of hinted at in that bullet point, we think this is going to be a heterogeneous reaction. Like, not everyone's going to respond in the same way. Many users perhaps don't even care at all about getting engagement, but there's going to be some who really do. And so we need to estimate this in an individual-ish kind of way. The second is, the key sort of tool that the platform has is the notion of promoting or boosting certain people in the algorithm. In other words, allowing them to be more visible, having more eyeballs on their content. So who should the platform boost is question 2. And the third question is, well, what happens now to outcomes that the platform cares about? We're going to be focusing mostly on platform usage, like the overall time spent on Twitter as the main outcome of interest. But we might also care about other things as well, like how much content is being produced, how regularly do people log in, and I'll show you some of those results later on as well. Okay, let me now touch upon the data in the setting here. We are certainly not the first people, in this room to be looking at social media. We are, I think, more closely related to this work you see here in the second big bullet point on peer engagement, feedback, and recognition. What's interesting is that this literature has had diverging results. There's some papers that show that there's basically no effect, that like even when people get more likes or they get more feedback from peers, it doesn't change their subsequent behavior. One paper that shows that there is an effect is a paper by Dean Eccles and some of his colleagues in 2016, where they ran a relatively large-scale experiment on Facebook, where some people got extra likes, and Eccles et al. Show that people do in fact increase their time spent on the platform subsequent to that. And our paper, I think, is most closely related to this Eccles work in the past. The key distinction, though, between what we're doing and what Dean and his colleagues did is that we are focused on heterogeneous treatment effects. Like, estimating the overall average treatment effect is not going to be enough for our purpose. We really have to be able to estimate these heterogeneous or ideally individual level treatment effects. And there's really one simple reason for this. It's because the intervention we're considering has to be targeted. It's that we cannot intervene for everybody. The specific intervention we have in mind is a notion of promoting or boosting some people in the recommendation algorithm. In other words, moving them up. And remember, the recommendation algorithm, or like the timeline, is a ranked list. You cannot move everybody up. If one person goes up, someone else at least has to come down. And so for that reason, looking at the average treatment effect isn't really enough for our purposes. What we have to estimate are these heterogeneous treatment effects instead. All right, so that's going to be our goal. We want to figure out which specific users are going to be most responsive, not just to characterize the overall average treatment, like that. Okay, great. So let's think. Is that a hand count?
It's a question about your research question.
Okay.
I understand we want to estimate heterogeneous positive treatment effects on treated users. Should we also be thinking about heterogeneous negative treatment effects on untreated users, given this rivalry that you mentioned?
Yes, potentially. I don't have estimate for you that I can talk about, but we can maybe talk later.
Okay.
What I will show, something that actually that you did not ask about, which is maybe a dangerous question for me to answer now. I do in fact calculate negative treatment effects for people who were treated, which I know is again not what you were asking, but I do have that as well. What you were asking, I think, if I'm understanding you correctly, is like among the people who don't get boosted, do they spend less time on the platform? Is that what you have in mind? Yeah. So I can describe loosely some of what we observed. That effect is actually surprisingly not very big. So it seems to be pretty minimal, at least in the time frame we're able to. Okay. Let's now talk about this notion. Yeah, Ron. Yes.
Show them, well, really want attention, maybe don't have to.
That is, I think, another potential concern. I am not going to show you results of that here. Actually, my answer is actually very similar to what I just also can, which is the effects seem to be close to zero for that audience as well. So it seems to not affect, again, in the short amount of time we're looking at, it doesn't seem to happen. Okay, let me talk briefly about this notion of like promoting people in the algorithm or boosting people. If you talk to people at one of these social media platforms about like, okay, which users should be boosted, there are tons and tons of, possible groups of people can come up with. And what you see here on the left is like various, I would describe these as like unidimensional groups. Like on one specific variable, we focus on people who have a high or a low value of this variable, and we want to potentially promote them in the algorithm. That is, I think, how these platforms have typically gone about things. And our approach here is going to be a little bit different. Our approach is basically to say that there's probably a lot of variables that are useful to look at. What makes sense is to estimate some kind of individual treatment effect and then focus on people with the largest treatment effect. So we're sort of kicking the can down the road in terms of like which of these variables are important, because frankly, I don't care about what variable it is that's underlying that. What I care about is the people who need to get boosted are the people with the largest treatment effect if they were to get boosted. That's sort of like the data forward way that we're going to be thinking about this. All right, so let me talk about the setting. I mentioned that we have data from Twitter. You will notice on this slide that I have a lot of past tense verbs, and that is because a lot of things have changed at Twitter from when I was working with them on this project. So we were working with them in late 2021. Since then, ownership has changed, the name has changed, the user experience, frankly, has gotten worse. So a lot of things have changed. And I bring this up for a couple of reasons. One is to point out that I am really only able to discuss what was happening in 2021, both in terms of like, that's the data I have, but also I don't really want to get sued by the current very rich, very litigious owner of the company. And so nothing I'm saying is really particularly indicative of X today. Imagine I'm talking about Twitter for 2.5 years. Okay. So at the time, they had about 250 million daily active users. As I mentioned before, like many of the social media companies, they make their money by showing people advertising. So that's what they were doing as well. And they have a recommendation algorithm, which is entirely consumer focused. I think the best comparison here is to the kinds of recommendation algorithms that you may be familiar with from like Netflix or YouTube, where the goal here is basically to show people what we think they're going to like. In the context of Twitter, what they were trying to optimize over was the probability of engagement. So the way you want to think about this is, let's say, you pull up the app on your phone, there's like 1,000 tweets that Twitter might consider showing to you at this moment. That's what they refer to as their pool of candidate tweets. For each of those items, they try to predict in real time, if they were to show this to you, how likely would you be to engage with it? And engaging here means one of 3 activities on Twitter. It's you reply, you retweet it, or you favorite it. So those 3 things constitute engagement, and they're trying to predict essentially how likely is that you will do one of those 3 things. And that probability is referred to as the score. So that term SIC is the score. They score each of these 1,000 candidate tweets, and then what you see on your app is simply those 1,000 tweets ordered by their score. So highest score is the first thing you see, then second, then third. If you keep scrolling down, you will start to see things that are less and less relevant for you. Yes.
Are separate weights assigned for each of those 3 activities?
At the time, no. My understanding is that they are now playing around with various weights, but at the time, no. It was just one of those 3 things happening. Yes.
So you're telling me that right now, out of the tens of millions of tweets that just came out, they calculate in real time the score of tens of millions times 250 million active users and have this gigantic matrix to the side? So in real time, SIC is calculated?
So it is only calculated if you are sort of opening it on the app, right? It's like, there's many, like 99% of users at any given time are dormant, right? So they're not bothering calculating anything for them. It gets calculated in real time when needed to calculate. So that
But
narrows
for all
down.
the content, right, like new content comes in, gets recalculated for everybody as you're going in.
So there are limitations there as well. I mean, the most notable limitation is something like language, right? So they're not going to show me tweets in language they don't speak. So things like that are helping to narrow down the set of possibilities. But you're right that there's still thousands of things that they could be showing me. And yes, they are doing this at a relatively large scale. Yes,
I'm looking at the tweet is not taking into account. It's just you interacting with them.
that is correct. Yes. Okay, great. So this is the recommendation algorithm that was, again, happening at the time. This is good for consumers in the sense that like consumers are being shown things that Twitter at least thinks that they're likely to engage with. And that is sort of, you know, how the content was being shown to most users at the time. Okay, so let me take a step back. As I sort of pitched at the beginning of this talk, our goal here is trying to figure out if you specifically get engagement on your content, how do you change your behavior subsequently? Let's try to think about how we can try to measure that specific treatment effect. One way is to look at different cohorts of users, like compare people who get a lot of engagement versus who get very little. I think we can all see why that is a flawed comparison. Like these two groups are just very non-comparable on many, many dimensions. And so therefore that is not a relevant comparison. It doesn't really help us figure out what is the effect of engagement on their subsequent activity. Here's another approach. Another approach would be to say, let's run an experiment. They have a big experimentation team at Twitter. Let's run an experiment. Let's vary the number of engagements people are getting. Let's see what happens to their behavior. Great. However, the issue there is that there's no way to do that because engagements are not something that are coming from Twitter. Engagements are something that are coming from your fellow users. And so the only way for us to run that experiment would be to lie. And I'm happy to report that we were not willing to do this, and nor was Twitter as the platform. So that's why we did not go this route either. What we have to do is a slightly more indirect way of generating variation in the thing we want to vary, which is the amount of engagements that people are getting. And here's what we're going to do. What we are going to assign people to are two different groups. On the left, you can see a control group. On the right, you can see the boosted group. I mentioned to you already that the way that content gets shown to people is through the score, SIC. And if you as a content producer, if you as a user on Twitter have been assigned to the boosted group in our experiment, I take all of the scores of your tweets and I multiply them by a constant positive factor, in this case, a factor of 16. And what's going to happen, therefore, is because I'm taking your score and multiplying by a positive factor, the score goes up, like the actual realized score goes up. Therefore, it's going to show up to more people are going to see your content. And that part is being done at random. The assignment to boost versus control is being done at random. We assign a third of our users to boost condition, the remaining 2/3 for control. And this allocation of boost versus control groups lasts for a 2-week time period in late 2020. Okay, so that's the experiment we are able to run. We put people into these two groups. Now, the logic here is as follows. I am randomly assigning you to one of these two groups. If you end up in the boosted condition, then more people are going to see your tweets, sort of in this mechanical way. And as long as your tweets are at least a little bit useful or a little bit interesting, on average, if the number of views you get goes up by a lot, you should also get at least some more engagements as well. All right, and great. Now that you have more engagements, I can see whether you change your behavior subsequently, and I can ideally try to estimate these heterogeneous or close to individual level treatment effects as a result. Yes.
The control group will get less and less harm.
Correct. So in a relative sense, the control group is being moved down the timeline slightly.
Assuming you're just comparing pretend control and overestimating.
If I were comparing treatment control, I would. I'm going to show you that comparison, and you're exactly right that there is this interference problem between the boost group and the control group. It's why that simple comparison doesn't work. So yes, you're exactly right. Yes, Andre.
I think this is, I'm not sure like it's the right model to think about it, but you can imagine marginal people here will be by definition people who are less interested in the content. Now they're shown this content. So the ratio of action to views will be lower. If what people care about is which percent of people who see this, engage with this, like it, you can have the opposite effect. It can be repetitive. sense how the people saw it, no one liked it. That sounds not great.
I think that's a concern, but the good news for us is that at the time, you as individual content producer did not know how many views you got.
I see. So do
That's
you-
not true anymore, but it was true back then. So the number of views was concealed
I see.
to the actual content producer. But they did observe these other like very more tangible notions of engagements. Yes.
What about the quality of engagement? So Steve related to that. If the matching is worse, do you see more toxic content or, hate speech? Do you actually look at comments or only like likes and?
So what you're discussing, I think falls under the bucket of replies, right? Like if you reply to someone who said you're stupid, like that would be a pretty mildly toxic reply, I would say. But yes, no, that may be happening. We don't have the content of the replies. That's the shortest answer I can give. So we're unable to evaluate whether people are getting hostile engagements versus positive engagements. Not only are we unable to do that, but actually for Twitter's recommendation algorithm, that wasn't relevant either. Like they count either of these things as engagements. And so that's why we're sort of using them. There was another hand a second ago. I think I lost over.
I got it, thank you.
Okay, thanks. All right, so cool. So this is the experiment that we're able to run. We run the experiment itself for 2 weeks in September of 2021. And we also follow customer users, I should say, for the 2 weeks before that to get a view of their like baseline activity on the platform, as well as the 2 weeks after the experiment, to see what happens afterwards. And it's the 2 weeks afterwards that are going to give us the outcome of interest here, because what I care about is once the experiment is over, how much time are you spending more on Twitter once you're no longer in this sort of like exciting experiment period. So in other words, we like turn off this like boosting faucet that some people are receiving. And what we care about is like in the 2 weeks post treatment, what is your time spent on the platform? One way to think about this, and I think the way that we're going with this is that the experimental treatment group, like whether you're in boost or control, is essentially functioning as an instrumental variable. It is affecting the number of engagements you're getting, and the number of engagements you're getting should presumably affect your time spent on the platform, but that is like the main causal path that we're one more terminology thing, I'll be referring a little bit later on to treatment intensity. You can think about this as just like as corresponding to the amount of engagements you're getting in the 2 week time period. I want to sort of hint early on that two users who've both been assigned to the boost group, for instance, might actually in reality receive very different amounts of treatment. If you just aren't very good at Twitter and you have like one friend on the platform, even if you've been assigned to the boost group, if you send out one tweet and it's just not that good, you might not get any engagements in these 2 weeks time period. Meanwhile, if like a celebrity, if Barack Obama gets assigned to the boost group, he's going to get like 100 million new likes just because he's already very popular on the platform, and so many people are going to see his content. Yes.
Exactly. 2 weeks post treatment, wouldn't that sound like another treatment situation where those happily engaged people, you suddenly remove that 16 times boost? That comes as another shock.
Yes, I think you're right. What we would like to do, I think, really is to look at a longer time period, but we didn't have access to that. And so I'm unable to see whether there's like almost like a post-promotion kind of problem. That's back there. Like, we're like, anyway, you got some like exciting treatment, you got a bunch of engagements, and then now you get depressed because it seems like your tweets aren't working as well as they were last week. That I think is not something that we're going to be able to talk about, at least not very. Okay.
Do you have any measure that people were aware of this or not? Does it mean the impact? Do they think that something has happened or stopped happening? Yeah.
I have somewhat of a common answer, which is like, I have no reason to think that they did. That, but of course, we don't know. There was nothing that the people at Twitter sort of noted as like, here's consumers behaving differently, or they're talking about the kind of engagement they did otherwise. Part of it might just be that I think everyone is a little bit arrogant about this stuff, and they think that, oh yeah, if I'm getting more engagements because this is what I deserve, and I'm looking at Twitter. That might be what's going on, but I don't have a good answer for you. Okay, let me talk to you about the data we have. So we have information in like these 5 big categories. These are our numeric variables that we observe about each individual user on the platform. And again, I want to be clear that we observe this during these 3 different time periods, 2 weeks before the experiment, the 2 weeks of the experiment, and the 2 weeks after the experiment concluded as well. These are the numeric variables that we observe. We have activity, engagement, send, engagement received, connections, and then some information about your device and your account. We have some categorical variables in addition to this. One of them is, this is a variable that Twitter uses themselves internally called user state. So they assign all of their users to one of these 8 different buckets. These are arranged from most active at the top to least active down at the bottom. I will say that our experiment is not a true random sample of the Twitter population. And the reason for that is because in order for you to enter into the experiment, you have to have tweeted. And that rules out many, many people, including someone like me, who never sets out any tweets on Twitter. So that's why this is, this is like the population that we're working with, but you should not think of this as representative of the overall, the entire platform as a whole. We also have information about what countries people are from. I was surprised to discover that they are very popular in Japan. Japan is they're like basically tied to the US in terms of how many customers they have on a regular basis. And we can see they're reflected in our breakdown of users here as well. Okay, let me now show you some preliminary analysis. I'm going to start actually, to Ron's question earlier, I'm going to start by showing you a comparison of the control group versus the boosted group. I'm going to show you 2 things. First, here on the left, I want to show you the treatment received, which you can read this as like number of engagements received in the 2-week time period that the experiment ran. What we're doing is we're comparing sort of like in the control group, these users on average are receiving about 269 engagements in this 2-week time period. Meanwhile, if you were in the boosted group, you are receiving on top of that an additional 456 engagements. This is clearly a huge difference between these 2 groups. This is about a 170% increase in the number of engagements that you get if you are assigned to the boost group rather than to the control group. So that just essentially is showing you hopefully that assigning people to the boosted condition is in fact dramatically, but in some cases, increased number of engagements that people are getting. Let's now focus on the outcome of it. The outcome of interest is producer activity, which is minutes spent on the platform. And in the control group, in the 2 weeks after the experiment is over, the average is about 590 minutes. Among people who were assigned to the boosted condition, it's an increase of about 6 minutes. That's roughly a 1% increase in usage once the experiment concludes. Not a huge effect in sort of minutes spent, but it is a statistically significant one. There are some issues here, though. So this comparison has a bunch of issues, some of which are statistical in nature towards the top, including the interference problem that Ron and I discussed previously. And there's also some managerial issues down here at the bottom. I really want to focus, for now at least, on this final point, which is I motivated this talk. I started the talk by talking about the fact that we want to potentially promote or boost specific individual users, which means that what we care about are individual treatment effects, and we are very far away from being able to do that. So that is, I think, is like the biggest problem with this current ITT comparison that I've shown you so far. Okay, here's a slightly better way of going about this analysis. We can use the boost versus control assignment as an instrument. So treat this as some instrument C. This now allows us to figure out what is the effect of every one incremental engagement that you might receive as a user. What is the effect of getting one engagement and how much more time you spend subsequently. That effect is positive. It's 0.0131 minutes. Again, not a huge number by any means, but it is a positive. It is a significant effect. And so that tells us that on average, when people are getting more engagements, they do in fact go on to spend more time on the platform. Okay. A lot of the issues I mentioned on the previous slide are still here. In fact, almost all of them are still here, which is why we're not using this analysis either. But this is sort of, I want to point out as like an intermediate step between a simple ITT comparison and where we're ultimately going.
Sorry, is the increase in engagement just me going into Twitter and just seeing the number going up, or do I actually stay the platform and check on the tweets?
Okay, so you said increase in engagement, but I think what you mean is increase in usage, right?
Yeah, usage, sorry. So it's different than it.
Correct. So we're defining usage for now as minutes spent on the platform, which, as you point out, could just be like you looking at a number and getting excited that the number's gone up.
Yeah.
But we do. I am later on going to show you that other metrics of interest are going up as well. So like the number of tweets I send out is going up. The number of times I favorite other people's comments is going up as well. On average, these other things of interest are also heading up. There was another hand a second ago, but we're good. Okay, cool. Let me now jump to the actual model we're gonna be using. I'll show you the two simpler models. Hopefully we're all on the same page as to why those are not sufficient for our needs. Our goal here is, as I mentioned before, to get as close as possible to an individual level treatment effect. We're gonna be estimating these conditional average treatment effects, these Kate values. And the Kate value, which is this term theta, represents something very simple. It is like, how would your expected activity on the platform go up if you got one more engagement compared to what you would have gotten? All right, so that's it. It is how much does the expected activity increase if the number of engagements goes up by one? And this term theta is going to be a function of your user features, your X's essentially. So that's how this is going to vary across different kinds of users. The only time it wouldn't vary would be if you and I, as individual Twitter users, have like the exact same set of X's on all the variables I showed. And we are going to try to model this flexibly, and I will show you in just a second what models we are using. Okay, but before I get to the model itself, let me explain to you how this is going to be useful for us. This slide is in some ways like the pitch we gave to the company when we started working with them. What we told them basically is that, look, your recommendation system is quite nice at potentially showing consumers what they want to see, but you are ignoring the fact that there are all these content producers who are being ignored in this recommendation system, at least as of now. And what we encourage them to do is to think about this instead as like a two-sided recommendation that accounts not only for what do consumers want to see, but also which producers want to be shown. So those are now the two things that we're trying to link together. I mentioned to you previously how the current recommendation system works. They're calculating these scores, these values SIC, which is the probability of an individual consumer engaging with a specific item. And we're not saying to throw that out, but what we are saying is that that term SIC should still be here, but we can multiply it times 1 plus lambda times these treatment effects theta. All right, that's the idea. So theta, remember, is the treatment effect that we're calculating. It represents, if you get one more engagement as a content producer, how much do you increase your time spent on the platform? If you multiply this out, what we get is a nice weighted sum of consumer utility and then lambda times producer utility. If you really want to value producers more than consumers, set lambda high. If you care about consumers more than producers, set lambda low. We think this is like a managerial question for people to deal with, but we think that this general framework might be closer to what they should care about if they really have the interest of both content consumers and producers in mind.
Social multiplier effects even possible. It's really, it's a little bit constant, that if the algorithm is really good at matching content that people engage with, and instead of boost some people, if they spend more time on the platforms, that they create stuff that people are less likely to engage with than what the original algorithm. Right, and then in fact, if those individuals are more engaged, these others to be more engaged. You could take it more hops.
Yes, you can. We're not going to go. I will show you the results later on for one more, which gets us part of the way there. I'm going to show you that actually it matters very, very little. But I will show you one hop. You're right that like you could think about this as like infinite series of ongoing connections that are going to happen. But hopefully these sort of one-hop stuff I'm going to show you later will help address some of these issues. Okay, great. So this is why we think that estimating these theta is valuable. It's because it allows you to now set up this kind of two-sided recommendation system, which is different than what they've done until now, but I think it's a better fit given that they have these two different kinds of users, both of whom need to be made happy in order for the platform to continue surviving. All right. Now, our model, I want to be clear that we are not taking any credit for the model itself. We are borrowing a model from the computer science literature. This is relatively recent work in causal ML from Serkanis and colleagues in 2015. The model in mind is referred to as a doubly robust instrumental variable model. So DRIV is going to be the acronym I'm using. We have two sort of kinds of heterogeneity going on in our context. We have heterogeneity in treatment effects, as I've laid out already, that we think like two different users who both get engagement might have very different responses. Like some people might not care at all, and other people might care a bunch. That's like one area of heterogeneity that we are able to deal with in this model. It also is dealing nicely with the heterogeneous treatment intensity problem. So I mentioned this like Barack Obama example from before. We know that like two users who've both been assigned to the boost group in reality are going to get but a potentially very different engagement during the time the experiment is running. And this model deals with that issue as well. It is doubly robust in the usual sort of ML sense, like it is able to be partially misspecified and still generate consistent estimates. Okay, let me jump to some results. Our key result here is going to be these conditional average treatment effect theta values. All right, so I don't have like a histogram to show you, but I'm going to show you some slices of what those thetas look like. What the average treatment effect in this context is 0.14. What this tells us is that on average, when one of our users gets one more engagement, they increase their time spent on the platform by 0.14 minutes, which is roughly 8.5 seconds. Again, that's on a per engagement received basis. So that is the average. You can see, based upon some of the other numbers here, that there's a relatively wide distribution. And I also want you to think about the fact that what really matters here is not most of these distributional measures. What the platform, at least in theory, and I think should care about is like the far right tail of the platform. Sorry, of the distribution. What we really care about is who really cares about engagement. Like, are there some users out there who, when they get engagement, are going to dramatically increase their time spent on the platform? That's the audience who we want to be focusing on, whatever intervention we have in mind. And the way we're going to think about this is to focus on the people in the top 1% of K values. And the people in the top 1% here have an average K value of 2.36. So that means that like when they get one more like on Twitter, they increase their time spent on the platform by almost 2.5 minutes subsequent to that. So that's great. These are people who are highly responsive to getting engagement, and that's going to be the kind of audience who we're focusing on. I want to try to characterize how people in that top 1% are similar or dissimilar from everybody else in the data. These graphs, I apologize, are a little bit hard to read. What I'm trying to do here is to show you on a bunch of the different variables we observe. I'm trying to overlay two different histograms. One in pink are the people who are in the top 1% of K values, and then in blue is everybody else in the data, the bottom 99% K values. Even though these graphs are a little bit hard to read, one takeaway you can potentially make is that they don't look that different on some of these variables. They do look more noticeably different on others. The way I would summarize it is with this sort of bullet point down here at the bottom left, which is the kinds of people who seem to be most responsive to engagement are established accounts who have been less active recently. So not recent accounts. It's people who've been around the platform for a while, but who are not still extremely active on a day-to-day basis. Like maybe they were excited about Twitter 5-10 years ago, but they seem to have declined in their usage more recently. That seems to be like a nice way of summarizing who is more responsive than others. Justin.
Could there be some like ceiling effects at play? And by that I mean, right, we said that the average user additional time being boosted receives, was it 450 additional likes, right?
Something like that, yeah.
So mechanically, they cannot spend 450 times 2.5 minutes on Twitter, right? So does that kind of just immediately rule them out from being in this top 1%?
It's a good question. I need to go think about that some more. You're correct that if you're already getting a ton of, okay, so here's another way I would frame what you're describing, which is if you're already getting a ton of engagement, you cannot be all that responsive to engagement because you're already getting.
At least based on this month, right?
Yes,
Based
that
on
is
the
correct.
Specification function.
That is correct. So like, for instance, like our targeting strategy is not going to tell you to go like, we're not going to say like, go give Justin Bieber more engagement because he's good. But he does not need anything from the platform. And even if he did, it would not affect his subsequent behavior. So I think we're on the same page on that.
Yeah, although you wonder whether or not maybe like other ways that we could kind of slice this, maybe not linear in terms of engagement time or something like that, could lead to, maybe it could be the case that some celebrities really do need more time, or really do need more likes.
I see. That is potentially true. It might be more true actually going back to something that Carl and Ron were talking about. Like maybe having these people on the platform is good for other reasons, like consumers are getting something out of it. But we think that's like a second order issue that we're not getting into at least for now. Yes,
Can I clarify on the previous slide on the magnitudes? Joel really right that 25th percentile has a negative effect.
that's correct.
And separately, the mean here is comparable to the previous mean about from the ID. So before it was 0.014, now it's 0.14.
Yeah.
So just try to how to think about this.
Yeah, that is a good question. The answer is, there's a couple things that are going on. The first is, the like 2SLS stuff I showed you earlier has some issues with it in the sense that model, I believe, like, it's not fully consistent given some of the treatment intensity problems we have going on here. So I don't fully believe those 2SLS results. Let's put it that way. That's why we're not just doing that. But you're right that it is, I mean, we're off by like a factor of 10. That, I don't have a better answer than that. I think there are some drawbacks with the 2SLS result. This is overcoming those. There is also, of course, uncertainty about these results as well. I think there should be like a topics that are opportunities, so I'm not showing those to you. It is some combination of these things that are going to affect.
Negative. Is there any theory where you expect people to get an extra like and decide not to come to the platform?
Oh, so that I have some answers for you. Yes. So one of the things that we believe is happening is that there's some users on Twitter who think they're just talking to their two friends, and then all of a sudden they get boosted and they're getting replies from strangers, and they're like, well, that's weird. I don't want that to happen. And they cut back on their time to the platform. The other possibility, and this sort of came up earlier, was like, not all the engagement here is positive. You might get negative replies, and that, of course, is certainly going to cause you, presumably, to cut back. So I don't think the negative part here is a problem. Like, I think there are people who really actually don't want more engagement.
We'll talk about offline.
Okay.
And I wonder if you split it by actions versus engagement itself. So if you see time on the platform versus actions, these stories make a lot of sense. It's about like, I don't want to post because I'm worried people will judge me.
Yes.
But looking at the platform, if someone is staying with stuff, I probably look a bit more. Anyway, I don't know. I'm not sure why it will affect engagement itself.
It's a fair point.
We can talk about it.
Okay, that sounds good. All right. So let me talk about some of those other outcomes that I mentioned to you previously. Like our key focal outcome is going to be time spent on the platform, because as I said, that is like most closely linked to the way that these platforms spend money. But we do care about, or like, sorry, I should say, platform cares about things as well. Like, do people log in every day? How many favorites are they giving to other people versus how many tweets are they composing? Are they providing downstream engagement to other users? It turns out that all of these things are going up, which is nice. Like, this is a good result in the sense that, like, if I get engagement as a user, I am increasing my behavior in positive ways across all these different measurable dimensions. There is, however, a downside, which is from a targeting perspective, these are not the same people with the highest values in all these different outcomes. In other words, you as the platform need to sit down and say, here is a metric we care about. Like, if you care about increasing time spent on the platform, great. If what you care about is like number of favorites given, great, but depending upon which of those you've chosen, you are now potentially going to be targeting a very different set of people. In other words, the people in the top 1% of Kate values are not identical across all these different groups, even though the average across all of them is still positive. It's basically like there's no free lunch here. You have to sort of decide what you care about before you decide who you target. Okay, let me now talk about targeting. I showed you this slide previously. I told you that, like, if you're trying to think about who do you promote in the algorithm, there's lots of different potential groups you might want to consider, but that our approach was going to be basically to focus on people with the highest Kate values. Like, I want to focus on people who are most responsive to one more engagement. And here is a summary table where I can show you like this hypothetical world in which we can funnel engagements to people. Like, if I can funnel one more engagement to the people with the highest Kate values in my data, the platform can generate about 115,000 incremental minutes. By comparison, here are some other groups that Twitter might want to consider targeting. And on the right is the group that they actually were funneling engagements to previously. In other words, before we got involved with them, they had a boosting system that was specifically focused at the bottom 1% most active. Think of these as like least active customers on Twitter. They even have like a fancy term for them. These were called lonely bird users. These are people, the assumption is like these are people who are on Twitter and are just like really sad because they don't have enough connections. And the people at Twitter believe that like we have to get these people to get boosted. That way they get likes and they'll cause them to behave better on the platform forward. It turns out that that theory, while appealing, just is completely ineffective. And I think as marketers, many of us will probably have guessed this. Like, if people aren't using your platform, it's because they don't want to use your platform. And no amount of giving them more engagement is going to overcome their reticence or maybe their displeasure at using the platform. Yes.
Sorry, could this be driven because of a difference in
you're maximizing a static problem, which is I have this bundle of users now, and I want to maximize the minutes today. Versus I'm trying to support the people incoming because some of them are going to be superstars in the future. So now I'm maximizing the present value of Twitter as opposed to the just today value. I think it's a fair point. Yes, because our experiment did not run for an extremely long time. I'm unable to say like what is like the long-term dynamics of how much time people are spending on the platform. What I will say is that this is not about new users. This idea that they were doing was about people who've been on the platform for a while but just aren't doing anything right now. So I agree with you that maybe in some other way it might be helpful to boost new users to help them get a community early on. That'll have positive effects for the long run. I think that kind of makes sense. It's not something that I can show you results for, nor is it what they were doing. That is sort of like what I'm trying to get at. Okay. This is related to the sort of one-hop stuff that I was talking about with Carl earlier, which is there are potentially some spillover effects here, right? And in the sense that if I get engagement, then there's a direct effect, which is I get engagement, maybe I'm going to spend more time with the platform tomorrow. There's also the fact that if I get engagement, I might go provide engagement to other people, and then now those people are going to spend more time on the platform as well. That's something we can try to measure here. We can now essentially calculate incremental minutes active that accounts for both of these, the direct effect of receiving engagement. In other words, I get engagement, I increase my time spent on the platform, as well as the indirect effect, which is sort of what am I causing other people to do that is going to help the platform as well. Now, what I want to point out, just sort of to preview the results here, is that this final term, which is the expected value of theta, like the average theta, is quite low. It's only 0.14. And therefore, this entire second part of this term is really, really small. And so for that reason, what we find is that when I compare columns 1, which is what I showed you earlier, which is let's just focus on the people with the highest K values, versus I now show you column 3, which is this like this one-hop analysis included as well. The results are very, very close. It turns out that including this sort of other step, this indirect step, almost has no effect on the incremental minutes at all. Yeah.
But is this an artifact of targeting the highest Kate users as opposed to the highest combination of Kate plus indirect effect on others' engagement?
So the second thing you described, I think, is what I'm describing here, because including your Kate
Right.
plus this stuff.
I agree. You're using this to measure the effectiveness of the targeting policy described previously. And I'm asking if this measurement could motivate an alternate targeting policy, which could lead to a larger improvement in this measurement.
I'm not sure I understand. What is the policy you have in mind?
A combination of both the high Kate on their own the direct effect of their own usage,
Yeah.
plus some other factor or function of their indirect effect on others' usage.
I believe that's what I'm doing, which is I'm calculating this, right? I'm calculating incremental minutes active. And then I'm saying, what happens if I focus on the people who have the highest Kate values when what I'm optimizing for is incremental minutes active? And that's what this third thing represents.
There's a good chance of misunderstanding, but we can talk more.
Okay, yeah, sorry. I have like 30 seconds, Joseph. Let me come back to you in a second. Let me just sort of wrap up here. What I wanted to summarize is the following, which is social media platforms have these two different kinds of users. We have content producers and content consumers. The survival of the platform requires us to keep both sides happy. You cannot survive with only people consuming, only people producing. And our approach here is to sort of basically think about this as trying to understand which users on these platforms really seem to value engagement from others, and estimating that, and then trying to figure out how do we target them with engagements forward. On the implication side, there's a couple of things I want to point out. The first is, this is a context where running an experiment on its own would not have been enough. Like, we run very quickly into these relatively severe interference problems. This, I think, is a nice example of a situation where running an experiment needs to get coupled with some like modern causal inference methods to estimate what it is that we really, really care about. And I've been talking about Twitter. I don't think there's anything Twitter specific really in our approach. And my hope is that this can get used more broadly in other similar contexts. All right, thank you all for your time.
All right, good afternoon, everyone. I'm in a tough spot, being a discussant after Puneet, who is a senior editor, and that's a real setup for failure, I guess. But I would like to first thank Ken, Davide, and including who is not here, for organizing the conference and for putting together such a wonderful program and for having me discuss this paper. There's a lot to like about this paper for many reasons, but before I get into the details, I would like to take this liberty to introduce my very intelligent student, Qixie here, because her work is relevant in this stream of literature about consumption, production on social media platforms. In her work, she looks at user engagement in terms of content consumption and exploration. Due to data limitations, we were not able to look at content production, but I hope she gets to talk to many of you throughout the day and tomorrow at the conference. Okay, so now let me get back to why I like the paper. Being a discussant for a good paper like this is both easy and difficult. It's easy because the paper is very well written. It's easy to follow and understand. It's difficult because every time while I was reading the paper, every time I got this comment or thought, then they have the next paragraph to discuss it, or they have a footnote waiting for me. So in fact, a lot of the questions that came up from Ron, Andre, from the audience, they have a paragraph discuss that particular comments. So I really like that. At the core, the paper really answers a very simple question, right? How does peer engagement affect content producers' subsequent behavior? Because for those social media platforms, they have very limited levers to actually control what users can do on the platforms. And the authors, they are not only looking at time spent, as Simha already talked about. They look at a variety range of outcome measures. For example, as a user on Twitter, you are both content producer and consumers. So they look at content creation in terms of the number of tweets posted, content consumption in terms of the number of favorites they gave to other users, and in the end, they also look at this possible spillover effects because the total number of engagements, retweets, replies, and favorites you're giving to others, that can subsequently increase or have some effect on their behavior as well. Right? Now, to put this paper in a broad literature, how does this paper fit in and contribute to the literature? Broadly speaking, it is relevant to this streams of research focusing on the incentives for content creation and content production. But more specifically, it's related to peer effect, right? Peer recognition, peer feedback. But what is unique for this paper is actually they look at the individual level treatment effect. Right? So the data they have allow the authors to actually do that, not like the previous literature. And finally, even though this question is simple, but addressing the question or answering that question is actually challenging because of the endogeneity concerns. So the authors actually used or applied a state-of-the-art type of methodology, doubly robust instrumental variable approach, to account for all these empirical challenges that came up from answering the research questions. Now, in terms of design, right, what makes it possible for the authors to answer the research question and address those empirical challenges is this very unique setting where they can run a field experiment on Twitter. And ideally, you want to exogenously shift how much engagement each user receive. So that's what they did here at the producer level. So they have these 4.9 million users split into control and boost conditions, and Simha already mentioned this in detail. So they have this 2 weeks period of time where for this, all the producers that were in the boost condition, all of their items are gonna be boosted by a fixed positive number to the relevance score. What's nice about this setting is that now instead of boost or give like that fake number of engagements, this way, if you were in the book boost condition, then that can exogenously shift the intensity of that treatment, like in terms of how many retweets, how many replies, and how many favorites that you get. As a result of that, the engagement that producers get is actually endogenously generated, right? So all they really need is this exogenous bucket between control and boost condition, and that allows the authors to actually use this exogenous treatment, exogenous assignment as an instrumental variable because it doesn't really affect the outcome directly. So that's what allows them to answer the questions and apply the method that they did. Now, the authors are very meticulous in terms of empirically examining the data, right? We already know that, they applied many different methods to analyze the data. And the paper is very careful and very detailed and clearly explaining why this final method has to be used for this particular context because all of these limitations associated with other potential techniques. So in the end of the day, they use this doubly robust instrumental variable that allow them not only to look at that marginal treatment effect in terms of how much you're gonna affect the producer's activity if you have this one additional engagement received. And then in the meantime, it can account for the heterogeneous treatment effect and heterogeneous treatment intensity. So I have to admit, I'm not an expert in this domain and this methodology, but I feel like I learned a lot by reading the paper. And in terms of the key findings, for all of these outcome measures that they have looked at, they always find this positive, on average, the positive impact of engagement on these. And when they look at content production versus content creation, right, we already know there is this positive overall effect on the number of minutes spent. But if you look at whether they are spending it creating the posts or whether or not they are spending time consuming the posts, they actually see bigger impact on content production. But what I feel like is more interesting is all these heterogeneity, these heterogeneous treatment effects, and they found substantial heterogeneity in these treatment effects who are most responsive to these engagement. And what's interesting is that for different measures, outcome measures, they find different characteristics of these most responsive users. For example, for those who, if we look at the total number of minutes spent on the social media platform, they actually found those who, like among the top 1% of Kate users, they are systematically different. They actually have more followers, following more accounts. They tend to be, the older accounts. They're not regular users who come to Twitter every day. But if we focus on the total number of engagement given, that's another outcome measure that they're looking at. The top 1% of Kate users is actually those who are less active on Twitter, who have less, in terms of activity like content production and engagement with others. So this led to their implication, what they can say to the platforms. In terms of the implications, they're saying, well, social media platforms can use what they found in the paper to target the top 1% of Kate, but that targeting would be dependent on the objectives of the platforms. It will be more effective to target users using their method, and if the platform focuses on the total time spent, then they probably want to target based on the total the more followers, more connected users, the older accounts, if they want, their objective is to focus on the downstream engagement by users, then they probably want to focus on the people who actually less active and less connected on the media platform. And finally, they didn't really play a bigger role in the paper, in the current form, but they did talk about how the platform can utilize this method to improve their recommendation system design in a way that can account for both the content production producers and content consumers. So that's kind of like a long overview of what I really like about the paper, what I learned from reading this paper. Now here, I'm just gonna offer a few thoughts that I have regarding either that they can do with current data that they have, or maybe have something down the road for future research directions. First, I feel like the paper already looked at, what are the characteristics of those who are most responsive in certain dimensions, total time spent, total engagement given. What I feel like it might be more interesting or addition to the paper is also to look at the most responsive in terms of content creation. Who are they who actually create more posts? Some of these characteristics that can help the social media platforms if they want to focus on like content production. Right? On the other hand, they can also look at the features who are most likely to respond in terms of content creation. And you already have the data, you already have these estimates, so it's an easy check to add to the paper. And that's actually related to some of later comments that I have. Now, secondly, I think Andre also mentioned this, there is this negative effect of engagement based on the estimates, and I wonder why and who are they? I know the percentage of the boost condition users, they're relatively small, so they may not, and whoever experienced the negative effects is even smaller, right? So it doesn't really matter maybe that much to the platform. But I think in long term, probably the social media platforms still want to know who these people are and why that is happening. And then I was also thinking about what are the potential reasons, right? Why engagements lead to these activities for different type of person. For these more connected and older accounts, maybe is it just serving as a reminder? For these less connected and less active, whether or not that's really just reciprocal, like I see someone like my tweets and then I'll just go and like someone else's. And if you look at in terms of content production and content consumption, if you can see if they actually match those characteristics, and that can maybe hopefully answer some of those mechanisms questions. I know it's hard to look into the mechanisms given the data, but that might be something that's useful to think about. And my final comment is about whether or not there's some learning going on for the content producers. You probably don't have the post data, right? If you do, then you can compare the posts that they actually tweet out, right? And then compare whether or not seeing some engagement from the users, then whether or not that actually let the producers learn what they're going to post out, what's they're going to tweet. Right? That's all I have, and thank you. And overall, I really love it.